In this lesson, I'll be covering joint variation and partial variation. So when we have joint variation, we have a quantity is proportional to two different variables. That is joint variation. It could be directly proportional to one and also directly proportional to the other, like we have in this case where y is directly proportional to a and b at the same time. So one quantity is proportional to two different variables. That is what we call a joint variation. Just as you already know, we are going to introduce the constant of variation and say y equals to k a b b. So this is how to interpret a joint variation. How about if y is directly proportional to p and inversely proportional to q, like we have in this case? So this means that y is proportional to p and the inverse of q. And when you introduce the constant of variation, you are going to have y equals to kp over q. And then to make your k the subject of the formula, all you need to do is to cross multiply. And then you are going to have k is yq divided by p right here. So that's my constant. And this example will help to put things in perspective. The question says the energy E possessed by a moving object varies directly as its mass and the square of its velocity v. When m is 8 kilograms, v is 5 meters per second, and E is 100 joules. Find E, that's the energy, when m is 6 kilograms and v is 2 meters per second. From the very first sentence in the question, we're told that E varies as mass and the square of its velocity. So that's the relation between E, m, and v square. It's both directly proportional to m and directly proportional to the square of the velocity v. So that means that I can introduce my constant like this and say E equals to kmv squared. Now that is my first equation, equation 1. M is 8 when v is 5 and E is 100. So I'm going to use these values to get my constant of variation. I said before, it is always important to find your constant of variation because that is when you can now write the full equation connecting energy with mass and velocity. So until you find that constant, you cannot have the complete equation connecting the variables. So what I'm going to do next is to put these values. M is 8, V is 5, and E is 100. And then I'm going to have K equals to 100 divided by 8 times 5 squared. That will give you K is 100 divided by 8 times 25. Eventually you have K is 1 over 2. Now, that's the value of the constant. Next thing is to put the constant into equation 1, the very first equation. So in place of E equals to kmv squared, I'm going to have E equals to half mv squared. This is an energy equation that many people are probably familiar with already. So when you have E equals to half mv squared, that's equation 2. And from here, I can put the other values and find the energy when the mass is 6 kilograms and the velocity is 2 meters per second. So what I'm going to do next is to put these values and find my E. And that's very straightforward. I'm going to say E equals to half times 6 times 2 squared. So when you do that, you're going to have E is 1 over 2 bracket 6 times 4. And finally, E is 24 over 2. E is 12 joules. So the energy when the mass is 6 kilograms and the velocity is 2 meters per second is 12 joules. So that's a very good illustration of joint variation. A variable is partly constant and partly proportional to another variable. So a quantity is partly constant and partly proportional to another variable. That's partial variation. So if z is partly constant and partly varies as the square of y, for example, we can write z is proportional to c plus y squared. C is already constant, so when I'm introducing my constant of variation, I'm not going to add another constant to C because a constant multiplied by a constant still gives us a constant. And when we talk about a constant, we mean a specific numerical value. If C was 100, for example, if I multiply 100 by 3, I still get a constant number. So that is why we only introduce the constant to the variable part. Z equals to C plus KY squared, where C is the partial constant and K is the constant of variation. So this example says the cost of sewing a garment is partly constant and partly varies with the time taken to sew it. If it takes 3 hours to sew the garment, the cost is $28 and $36 for 5 hours. Find the cost if it takes 2 hours to sew the garment. So you have been given some parameters already, and you just need to plug in the values into the equation connecting the cost and the time. Next thing I'm going to do is to say let the cost be given by C equals to A plus BT, where A is the constant portion of the cost or the partial constant, B is the variation constant, and T is the time in hours. So this is my equation for cost and the time. Okay, so now we plug in values of time is 3 hours, cost is $28. So A plus 3B equals to 28. You can turn it the other way and say 28 equals to A plus 3B. All right. We are still going to find the constant A and B. So you will notice that we generate two different equations now, and then we can solve them simultaneously to find the values of A and B before we proceed. Now, we are also told that if it took 5 hours to sew the dress, the cost to be $36. So I have A plus 5B equals to 36. So what I'm going to do is to subtract equation 2 from equation 3. This is equation 2. This is equation 3. So when you subtract, you're going to have A plus 5B minus, this is A plus 5B here, minus A plus 3B here, equals to 36 minus 28. And that is what I have here. So you will notice that A minus A goes out. That turns to 0. 5B minus 3B will give you 2B. And all you need to do here is divide both sides by 2, and you have B equals to 4. Now I can substitute B equals to 4 in any of the equations. Let's use equation 2, for example. I can have A plus 3B equals to 28. So in place of B, we put 4. So we have A plus 12 is 28 and A equals to 16. Now we have the values of B and A. We were told to find the cost if it takes 2 hours to sew a garment. Now what I'm going to do is to come back to equation 1, plug in the values of A and B, and then I have the perfect cost equation. Now we put the values of B equals to 4 and A equals 16 in equation 1, and you are going to have C equals to A plus BT becomes C equals to 16, which is A plus 4T. Remember, B is 4. So this is now the cost equation. With this equation, I can predict the cost for any time in hours taken to sew that garment. So the journey we have been taking so far was to generate this cost equation here. You see, we have to find the part constant A, we have to find the second constant B, so that we can now have a model to predict the cost for whatever number of hours given to sew a garment. So now I want to find the cost if it takes just 2 hours to sew a garment. I'm going to have C equals to 16 plus 4 times 2. That is 16 plus 8. That gives us $24. So I believe that these examples have helped you to understand the concept of joint variation and partial variation. So please let me know what you think in the comment section, and feel free to share this video and spread the knowledge. Don't forget to subscribe to the channel. I'll see you in the next one.